Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 8 of Azure Zero to Hero series, and in this video we will explore interview questions on the concepts that we have learned from day 1 to day 7. Typically we started with understanding cloud computing fundamentals, then we learned about resources, resource groups, then we learned about virtual machine, how to connect and deploy your first application on the VM. Then we understood about the VNet, the concept of virtual network. We learned about subnets, network security groups, application security groups, firewall, Bastion. And now it's time to put your knowledge to test. So I have some 9 to 10 interview questions, and let's see how many of these questions you can answer. Let's start with question number 1. That is, what is the difference between NSG and ASG? You can pause this video here, try to answer yourself to this particular question. If not, anyways, I'll answer this question. So I have some notes written, but what I would prefer is explain you first and then show you the notes. Typically notes is just for you to put the answer in a better way. But first you need to understand the concept, right? So if someone is asking you the difference between NSG and ASG, a lot of people answer this question wrong because they try to compare this concept with the concept of NACL and security groups in AWS. But this is not right. They are different. Do not try to compare all the Azure resources with the AWS because many of these concepts are different. Of course, the design of it might be same, but the implementation point of view, the concepts are different. The best example is NSG and ASG. It is different from the concept of security groups in AWS. So how this works typically is that, let's say, I'll give you a practical example. Assume there is nothing called ASG. If ASG does not exist, so if you have two subnets, okay, let's call the first subnet as the business logic subnet or the app subnet, where you have your applications. And let's call this subnet as your DB subnet, where you have the databases. Assume you have one of the database here, and you have a lot of applications. Let's call this as login application. Let's call this as logout application. Then probably you have payments, transactions, catalog, billing, customer information, customer support. Let's say you have these multiple applications. And also these applications probably might be created using the scale sets, the virtual machine scale set. That is, these applications or the virtual machines are subjected to scaling also, where there can be multiple replicas of each of these instances. Now the requirement is that login and logout, these two things should not be allowed to connect to the database, whereas rest all of these things should be allowed to connect to the database. Okay, that is, they should be able to send a request to the database and receive the response back from the database. But if these things are trying to access the database, then they should not get the response. This traffic should be blocked, but this should be allowed. So that means you should not be allowing entire subnet, but you should be allowing a particular group of instances. If ASG does not exist, you can still do it using NSG. So you can place a NSG to the subnet, or you can place an NSG to the database. Let's say you place the NSG directly to the instance. You have attached this. And in the ASG, what you can do is you can go to the inbound rules. And in the inbound rules, you can provide the IP addresses of all of these things and say that, okay, these IP addresses should be connected to the database. Right? Very simple. Just go to any network security group. Okay. If I have to quickly show you, this is one of the network security groups. What you can do is you can go to the inbound security rules, click on, let's say, let me show you one of these security rules. Okay. So you can just provide the IP addresses here and list of IP addresses, and they will be allowed. But what if this list of IP addresses is huge? And like I told you, these applications can also be placed in front of a load balancer. and probably they have virtual machine scale sets, that is the scalability in place. Tomorrow this can scale to 10 instances also. So providing IP addresses will be a practical problem. You have to continuously keep updating the IP addresses, or you might miss some of the IP addresses. So in this particular use case, ASG comes handy. So ASG is used in combination with NSG. Okay, so ASG and NSG, you should not be comparing the differences between them, but practically they actually are used in combination or in conjunction. So what you will do in this particular case is you will group this particular virtual machines, okay? Or you can also assign it at the VMSs or the virtual machine scale set level. So if you group all of these virtual machines, create an ASG and assign the ASG to all of these virtual machines, then your life becomes very simple. So what I can simply do is, let me open one of these rules to just show you. So in the source, I can, instead of selecting IP address, I can simply select an application security group. Right now, I don't have an application security group, so it doesn't pop up. But as I create an application security group, my job is easy. And creating ASG is also very simple. Just search for ASG. And you can create ASG by just clicking a couple of buttons. And the rest thing is just going to your virtual machines and assigning this ASG. Of course, you might say that, Abhishek, even assigning the ASG becomes difficult. But the advantage you get is, one is you don't have to provide so many IP addresses. These IP addresses, might change. If the IP addresses are changing, that is one problem. If you are using scalability with these instances, that is second problem, right? By using ASG, you can solve all of those problems. So to explain this answer, you can simply use this explanation. ASGs are applied to virtual machines and are used in conjunction with NSGs. By associating an ASG tag with a network security rule, like I just showed you, you can define rules that apply to group of virtual machines. Perfect. So this is how you explain the difference between ASG and NSG. Actually, it's not the difference. Now let's move towards the question number 2. Can you block access to your virtual machine from a particular subnet? So this is again a scenario based question. Usually this question is asked in this way, where again, let's say you have a subnet, and within this subnet, let's say you have deployed your application. Let's call it the DB application itself. And then there are multiple other subnets in your virtual machine, in your virtual network. If this is the virtual network, okay, so this is the DB subnet where you have the database, and here you have some applications in a different subnet, and then you have a firewall in the firewall subnet. Probably you have another subnet here, another subnet here. And what I want to do is I want to block access to this DB, let's say from all of the subnets or a particular subnet that is here. Let's call this as XYZ subnet. And I don't want applications inside this subnet to access the DB. Now this question is tricky because by default, within the virtual network, access from or within the subnet is completely allowed. That is, this subnet can by default access this, firewall can by default access this, and this particular application in the subnet can access this, because if you can just go to any network security group, okay, just go to any network security group, and in the network security group, you will find for every network security group, there is a default rule that is created. You cannot modify this rule. So this is the default rule, allow VNet inbound. Okay, so what is this particular rule says? So it's an allow action, and what it is doing is it will allow the traffic within the virtual network. So in last class, we have created an virtual machine, right? So if you go to that virtual machine called Nginx Web, so this virtual machine is also assigned with the network security rule. I will show you. And in this network security rule, you have this allow VNet inbound. And what this is doing is it is allowing traffic within the virtual network. And the requirement is that you have to block a particular subnet. So for that, what you can simply do is create one more rule, right? So the rule should override this particular rule, where here you are allowing each and every traffic, all the traffic to your virtual network, sorry, to your virtual machine. And now what I have to do is I have to create an additional rule, that is just click a port rule, inbound rule. And what I need to do is I need to deny, the action should be deny. And let's say you provide all of these things, what should be your source IP address, you can provide the CIDR range of the subnet. That's not important. But what's more important is, one, you select action as deny, and two, you have to provide priority that is lesser than this. The priority lesser means you have to provide a lesser number than 65,000. So in NSGs, how does it work? The rule with less priority number. So here the priority number is 300. That means it has the highest priority amongst all of these rules that are configured. The lowest number that you can give in the priority is number 100. So the priority numbers are starts with 100 and goes to something like 65536. I don't remember the exact number, but it goes to a particular thing where 100 is the one with highest priority. Number is lowest, don't get confused. The smaller number that you put, the priority is more. Higher the priority, smaller the number. And the least number that you can put is, of course, 100. So what I have to do is, because there is already a security rule that is assigned to my instance, which says allow VNet inbound, that is allow all the traffic within the virtual network. So I have to create a number that is smaller than 65,000 and deny the traffic from a particular subnet. Only then the traffic will be denied. So this is your question number 2. You can give it a try. In last class, we have created a virtual machine. So you can just give it a try, but otherwise the explanation is available here. Let's move to the next question. So the next question here is, are Azure NSGs stateful or stateless? So the answer is that the NSGs in Azure are actually stateful. What does stateful mean? Stateful means if you are sending a request to your application, okay? So from internet, you want to allow access to a particular virtual machine. Best example is when we created a Jenkins application in day 4. What did we do? So we created a virtual machine and installed Jenkins on it. And I want to provide access to that Jenkins from the internet. So the simple thing that I did was I allowed the port 80 from the internet, and I did not allow port 80 or I did not allow any outbound traffic, but someone, when they sent request to the virtual machine, they also got the response back. Let me explain this. So what did I do is I created a virtual machine and I installed my application, and from the internet, right, there is a user, and I said to the NSG of this particular virtual machine, allow port 80 from the internet. So this user has sent a request. So the request is on port 80. So this NSG said allow, but the virtual machine, the application inside the virtual machine should also send the response back, right? User has sent the request, but you have to send the response back. That can be a HTML page or that can be anything. So when we send the response back, there is something called as outbound rule also, but we are not creating anything in the outbound rule. If you remember, we just created an inbound allow port 80, but we did not create anything in the outbound. So this nature is called as stateful. Okay. So what does stateful mean is, whenever the NSG is receiving a request from the user, that is allow port 80, NSG remembers your request. Okay. It remembers that, okay, the user has sent a request to port 80, and in the network rules, we have allowed that particular thing. So when this particular application is sending the response back, I should allow the response, although that is not mentioned in the outbound configuration rules. This nature is called as stateful. If at all NSGs were stateless, just like security group, just like NACLs in AWS, then what would happen is you should also allow that in inbound and outbound, right? So this is the question, and the answer is NSGs are stateful in nature. Let's move to the next question. So next question here is, what is the difference between Azure Firewall and NSG? This is very simple. Firewalls are applied for both inbound and outbound traffic for a particular virtual network, whereas NSGs are usually applied for the VMs or for the subnets. So mostly we were playing around with the virtual machines. So we applied NSGs to the virtual machine and we have been trying out. But we can also apply NSGs to the subnet. So that's what is mentioned here. Typically associated with subnets or individual networks, network interfaces to control the traffic. Whereas for firewall, they are designed for the virtual network altogether. Next question. This is very important, not from the interview point of view alone, but this is very important if you are working in an organization. You need to understand what are the advantages of resource groups. People know that resource groups are mandatory resources that you have to create. Like whichever resource that you want to create in Azure, you have to have a resource group assigned with it or associated with it. But what are the other advantages? Of course, I made a dedicated video on this and explained. That is the day 3 on this particular series. But to provide a high level information here, if someone asks you this question, say that resource group one is they are used for logical organization of resources. Well, let's say you have a project, and in that project you have developer environment, staging environment, and production environment. And that product has 10 applications, couple of databases, one caching server. So you can group all of them into one single resource, that one single resource group. So by grouping that, you can do the lifecycle management. Tomorrow, if you want to delete them, let's say you're playing in the free trial account. So simply you can delete the resource group, or you can also tag them using the resource group tagging. You can control the role-based access control. I've shown you when I've created resource group. If you go to the resource group, you can control RBAC. If there is a new DevOps engineer or there is a new application developer, you can just go to the resource group and you can just grant them the access, and all the resources access is granted. Cost management, for sure. It's very easy to track the cost of a particular project using the resource group. You can just look at the resources billing and understand how much cost is being spent on that particular project in an environment. Resource group template. So basically this concept comes when we learn about Azure Resource Manager. Similarly, resource locking also we did not learn at this point of time. And I explained this during the day 2 as well, or day 3 as well. So how do you define a resource group? It depends on your organization to organization. It differs. But one of the best practices is for the product that you're working in or for the project that you're working in, there can be different environments such as dev, staging, and production. So try to group the resources of a particular environment. If I'm working for Nike sales, so I'll create one for Nike sales development, one for Nike sales staging, one for Nike sales production. But the opportunities and options are endless. It's up to you how do you manage, but this is one example that I would give. Next question. What is the difference between Azure user data and custom data? Again, this is a tricky question because a lot of times people try to compare AWS with Azure. Like I told you during the explanation of the first question as well, if you try to compare the network security groups and application security groups with AWS security groups and NACA. Similarly, here, if you try to compare Azure user data with AWS user data, then, it's a wrong assumption because AWS user data is actually similar to Azure custom data. And Azure user data is completely different. It does not exist in AWS if I'm right. But okay, for now, the AWS user data is actually similar to Azure custom data. And what exactly is custom data? Basically, they are used for the cloud init purpose, where Let's say you have a virtual machine. I have explained this in the last class, but I'm still doing it again. Let's say you have a virtual machine, and during the creation of this virtual machine, you want to run some scripts on this virtual machine. Best example is when you are creating a virtual machine, you want the application to be installed. So what you can simply do is, whether you are creating it through the CLI resource manager or through the UI, you can just provide the custom data as a script to the virtual machine creation logic, and that will automatically create virtual machine and install whatever is available in the script. If your script asks for installing Nginx, then you got the virtual machine plus Nginx installed in it. What is the advantage of it? Simple advantage is, one is, you don't have to log into the virtual machine again and execute the script. Let's say if this is in the private subnet, you don't have to log into it and execute the script. Other thing is, when you are using virtual machine scale sets or the scalability option, your virtual machine will be automatically scaled to 2, 3, 4 virtual machines. Then you don't have the time to log into this virtual machine and run the application, right? Because there is a load balancer, and load balancer might forward the request immediately as soon as this application is scaled. Just as an example, then what would happen is the request that is going here will not serve the traffic, or the load balancer health check might automatically fail, and there is no point of auto scaling also. So this instances will not get the traffic. So in such situations, we will also use the custom data. This is one example. The other thing, if you go to Azure user data is basically a advanced version of custom data. You can just assume it as custom data plus plus. That is an advanced version of custom data, where if you are using custom data, the script that you are passing to it will not exist, or it will only execute once. That is during the provision of this virtual machine. Once the virtual machine is provisioned, next time if the virtual machine is restarted, rebooted, this script does not get executed again. Whereas if you are using this user data, the advantage is that this particular script that you're passing through the user data, that will exist throughout the lifetime of your virtual machine. Even your virtual machine is restarted, rebooted, the user data script is always available. That's a simple difference between user data and custom data. But the thing is, do not try to compare it with AWS. In AWS, the user data that you use is Azure custom data. So that's what I explained. User data is a new version of custom data, and it offers added benefits. User data persists and lives in the cloud, accessible and updatable anytime. Even once your virtual machine is created, you can pass the user data, but you cannot do that with custom data. Custom data vanishes after the first boot, accessible only during VM creation, right? So this is the concept of user data and custom data in Azure. Yeah. Then comes the next question. That is, what is the difference between Azure App Gateway and Azure Load Balancer? I explained this in one of the videos, but I'll do it one more time. And I'll do it in detail when we move towards the load balancer concept. But because anyways we talked about it, let me explain this. So Azure has primarily two databases. One is App Gateway. App Gateway is typically a L7 load balancer. And then you have Azure Load Balancer, which is L4 load balancer. This is the primary difference, but it becomes very difficult to understand this way, right? If I say this is a L7 load balancer and this is a L4 load balancer, kind of difficult to understand. So let's try to understand a real use case. Very simple. If you have 2-tier application, or if you have 3-tier application, right? Tier 1, Tier 2, and Tier 3, let's say. And this has your web application. Let's say 2 copies of your web application. And let's say here you have the business logic application or the backend application, and here you have the database. Okay. So now the thing is, and here you have 2 copies of your application as well, let's say, just for the purpose of load balancing. So the load balancer that you will place in front of your web server will be a L7 load balancer or the app gateway. And the load balancer that you will place in front of your backend applications or the business logic applications is an L4 load balancer. Why? Because the L7 load balancer is a kind of powerful load balancer which can perform HTTP host-based routing, path-based routing. So this is a rich operation that you do, and probably this one decides, let's say if someone accesses www.xyz.com/login. Okay, so this is the L7 load balancer which intercepts the request that you are sending at the layer 7, that is at the HTTP layer. I have explained the layers during the networking fundamental class. So L7 load balancer intercepts your request at the layer 7, that is at the HTTP layer, and it performs the routing depending upon the action that it has to take at the layer 7. Suppose you have configured this load balancer for the path-based routing, and you said if you see /login, send to this particular web servers. If you find /logout, then send to a different web server altogether, right? So these kind of operations you can perform at the layer 7. Then once the web server is identified, now this web server, because this is a 3-tier application, web server, this web server and this web server has to forward the request to either this application or this application. So again, you can configure a load balancer here, and this will be a layer 4 load balancer. The reason why you choose a layer 4 load balancer here is basically if you are intercepting the request at the layer 7, it's one, a costly process, a rich process. Second one is this layer 7 load balancing is, kind of it takes more time compared to layer 4 load balancing, because here you will just perform load balancing using IP address and kind of port. So it is not performed at the HTTP layer, but it is performed at the layer 4, depending upon IP address based routing or something like that, right? So layer 4 load balancer for your backend applications, layer 7 load balancer for your web applications. You'll find it more detailed when we move towards the concept of load balancers. We have a dedicated class, don't worry. But I put the same thing here. Additionally, at layer 7 load balancer, you can also perform web application firewall WAF capabilities. Now, this is my favorite question. That is, it's a scenario based question where you have to explain the answer. There is no right answer to it. Assume your company is using an ideal Azure networking setup, and your application is deployed in the web subnet. Explain the traffic flow to your application. Okay, so the scenario is that assume there is an ideal virtual network setup, and you have to explain this ideal virtual network setup as well. So there is this virtual network, and the only hint that the interviewer has given us is there is something called as web application subnet. So let's call it as web subnet. And your application is deployed in this web subnet. So explain how can a user access this application in the web subnet. And this virtual network is set up in an ideal way. So what is this ideal way? That is, interviewer is indirectly asking you, how would you set up the virtual network, create this web application, and how will you enable the user to access the application, right? So the first thing that I would do is explain the interviewer that, okay, for the virtual network, I'll firstly configure a firewall. Just like we did in day 7, I've explained this entire demonstration, but I'm again trying to explain this as interview answer. Whatever I'm explaining now is actually demonstrated in day 7. So I'll create a firewall, and what I will do is, if there is some hacker or someone, I'll configure the firewall in such a way that the hackers will not be able to bypass the firewall. But if there is a user, then the user can actually bypass the firewall. And what I will do is I will perform a natting. So I will go to the firewall and I will configure this natting rule. I've shown you how to go to the firewall and create this natting rule. And what this natting rule does is user will actually access the firewall, and the request will be translated and sent to this particular application. And in the application, I will create some NSG rules. And in the NSG rules, I can configure allowing of traffic, denying of traffic. Even if some way the hacker bypasses the firewall, I can use the NSG to block the traffic, right? And additionally to this particular setup, what I'll also do is I will create a Bastion. I'll use the Bastion service of Azure. This is because apart from the user, if there is a DevOps engineering team, and if this DevOps engineering team wants to add any particular packages to this particular instance, so they should be able to SSH to the virtual machine. So for that, for DevOps engineers, we will create a Bastion. Through the Bastion, DevOps engineers will able to access this particular thing. So this is the best explanation I think you can give. And even if interviewer is asking about a 2-tier setup or 3-tier setup, it's very simple. What you will simply do is in an enterprise level, you will place a load balancer here, right? And this load balancer is called as App Gateway Load Balancer. So from the firewall, request actually goes to load balancer and then it comes here. And then from the web application, request goes to L4 load balancer and it comes here. If you want to explain even in a detailed way, you can also explain about Azure DNS. So the request, when user types something in the browser, actually the request goes to the DNS and gets resolved to the firewall or the load balancer IP address. So this is about the question number 8 or 7. Sorry, I forgot. But let's move to the next question. So all these things that you are seeing on the screen, I'll provide this in GitHub. Don't worry about that. And if you want the presentation, you can also get the presentation. One is you can pause the video here and try to read it. But the second thing is I'll put the presentation on the Telegram channel as well. Link to the Telegram channel is in the description. Okay, we have the last question. So this is, what is the purpose of Azure Bastion and what are the advantages of it? So this question can be asked in different ways. One is I just explained, how do you connect to a private instance, right? The application that does not have a public IP address. One is we use the Bastion. Interviewer might ask you question in that way also. But what are the advantages of Bastion? Like we saw in the last class, Bastion gives us a secure remote access. You can eliminate the use of public IP address or the public exposure to your virtual machine. Again, the one that we saw in the last class. Reduced attack surface, obviously because the instance is not exposed to the public, so you will have a reduced attack surface. Bastion integration, simplified connectivity. All that you need to do is just go to the Bastion and provide the username password or provide the private key. Portal based access. Of course, I've shown you in the last class, you can simply go to the Bastion service and through the Bastion service itself, you can access it. RBAC, you can control who can access the Bastion, who can access the instance. Multi-factor authentication, because you are going through the Bastion, you can set up the multi-factor authentication. Audit and monitoring. That is, you can verify who is actually logging into the Bastion. You can perform the monitoring through the Bastion. So these are the questions that I have. And let me know in the comment section, how did you find these questions? So it took a lot of time to prepare these questions because I have to sit down, write the questions, write the answers. And depending upon what we have learned, I also try to put it. Some of these questions might be tricky because while we are learning theory and while we are doing the practical, you might not come across these things. So again, I try to cover those things also in the interview questions. So this is the video for today, and I hope you enjoyed it. See you all in the next one. Take care. Bye-bye.